Hello, now we are going to look at construction 2, which is going to give us the perpendicular bisector of a line segment. So there's lots of different language to that. We're going to look through each word in turn. Perpendicular means at 90 degrees to, or at right angles to, and its symbol is an upside down t-square. And this is what it looks like. The purple line is perpendicular to our line through AB here, this line going across. And whenever we have perpendicular lines, the slopes have a particular relationship. The slope of AB multiplied by the slope of L would give us the number -1, or put another way, the slope of AB is the negative reciprocal of the slope of L. So we also have the word bisector. We are going to bisect the line segment between A and B. Bi means to, sect means to cut. So we are going to have a bisector that cuts the line segment in two. The purple line cuts the distance between A and B in two, so that means the midpoint of A and B is on the purple line. Finally, we have segment, and the SEG part here is connected to the SEC part in sector. It also means to cut, and the cut that's being referred to here is there's an infinite set of points going through A and B, and we are looking at the little cutout of the line, the little section of the line that is between the point A and the point B. So that's all of the different language that we've got for our construction. And the way that we would write that in more geometric type language is the line L, the purple line, is at right angles to, is perpendicular, the line going through A and B. And because it's bisecting it, the distance, so our vertical lines mean distance from A to M is going to be equal to, the same as, the distance between M and B, because it is the midpoint of them, because the purple line is bisecting, is cutting into two equal pieces the line segment AB, and that means that the midpoint of AB is on the line L. It's an element of the purple line set. The point is on the purple line, so it's a member of that set of points. With all of that done, we can now construct our purple line on this segment here. So what we're going to use is a compass and a straight edge. So we're going to take our compass, we're going to put the point of the compass at one end of our line segment. We're going to open up the compass to more than halfway to the other point. If it's not more than halfway, the arcs that we're going to draw won't be able to reach each other. So if we make it too small, we'll very quickly see our arcs don't cross each other. So we want to go more than halfway to the other side. That's well over halfway to the other side. So we're going to bring up our compass, and we're going to draw a nice big arc. We can go all the way, or we can just go above and below. It's a little bit up to you. And then we can take our compass, keep it at exactly the same size. It is important that it is kept at exactly the same size. And then we are going to draw an arc around again. And again, if we hadn't gone more than halfway, those arcs just wouldn't cross each other. So now what we need to do is take our straight edge. In this case I'm using a ruler, but any straight edge would do. And I want to line it up with my where my arcs cross each other. And now what I'm able to do is draw a line through where those arcs cross each other. And that is going to give me the perpendicular line, or the perpendicular bisector of my line segment. So what is equal in this situation? Well, what would be equal? I know that this length here, from here to here, must be the same as the distance from here to here. And I know the distance up here would be the same. And I know the distance down here would be the same. Here would be the same, and here would be the same, because the arcs were all the same distance. All of those lengths must be the same. So I am able then to mark in a lot of lines that would be equal, And I would be able to use that to try and give myself an argument for why this is working. Why do we end up with this length being the same as this length? And why do we end up with a right angle here? And a hint is that we can look for all of the different congruent triangles, all of the different equal triangles that we can create, and see if we can construct an argument for why this length has to be the same as this length, here to here, must be the same as here to here, and why this must be at a right angle. So again, look for congruent triangles that we can draw, triangles that must be equal in size and therefore equal in angles. So that is how we can construct our perpendicular bisector and that of a line segment, and that is what we need for now.